Okay, this is homework 2, part B. So for this one, we need to using a force balance on a rectangular prism, demonstrate that the buoyant force is equal to the weight of the fluid displaced. Explain how this extends to an arbitrary shape like a human body. So I've already drawn our rectangular prism. So in this we have our height from the top of the water, call that little h. Then we have the height of the object itself. That will be big H. So in this down here, this distance would be H plus, or little h plus big H. And that's this right here. And so know that the water exerts a force on the object on both sides. So at the top, we have this pressure and this pressure. And we also have this area we're worried about. And then also finally we have the density of water. Okay, so we know that the pressure at the bottom is equal to the density of the water times the gravitational force times little h plus big H. So that's the pressure at the bottom. We also turn this into a force. But the only thing that changes when it's a force is we're going to add the area. So this is force going up. So density of water times gravity times little h plus big H times area. Okay, so now that's the force going up. Now I need the force going down. So that's going to be very similar. But for this one, for the height, all we need is a little h because it's at the top. Times area. All right, so now what we need, we can find the net force. So F net is equal to, so what we're going to do is we're going to subtract these. So then we get density of water times gravity. And so we subtract these, all we're left with is big H times area. And if you notice, this is the density of water, that's what we're concerned with, and this is the volume, and this is the gravity. So it's the force net is equal to the weight of the displaced water, and that's it. If you want to do something like this for something like a human body, what you would do is you would just like cut up the body into like rectangles like this, and then you can add them all up, and that's how you would get the net force or the weight of the body. And that's how you do that.